Hey everybody, this is Larry. It is day 16 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join the Discord, and let's get started. Best time to buy and sell stock through. So yeah, in a way you could buy and you could complete at most 2 transactions. Okay, so this one's a little bit tricky for me in the sense that, you know, there is a harder version of this problem where it's for K transactions, where K is an input. And I do know, I do vaguely remember that one, so it makes it a little bit cheating for me, to be honest. But the way that I would break it down is to just keep track of all the possible states. So I'm going to do it in a very naive, or not naive, but just like a very specific kind of way for this problem, knowing that we'll take care of the 2 transactions. And yeah, and so the solution that I'm going to present is a little bit hacky, I believe. I think I have an idea about how I want to do this, just to kind of give you an idea of how to work out a solution, even if it's not the best solution or the cleanest to write solution. And if you really want the clean solution, just do a YouTube search on best time to buy and sell stock. I forget what the number, but there's one with the K days, and you should be able to find me solving that one in a clean way. But this one, I want to play around with different functions, and so that we can talk about it together. So this is going to be dynamic programming. If you ask why, the question is because it's just that's how do I explain this? So the reason why it's dynamic programming is just some of it for me. How do I figure out it's dynamic programming? Well, it's just because of experience, to be frank. And that's what practice gets you. I've solved similar problems, and I know it's going to be dynamic programming. But yeah, so what are the different states, right? The different states could be, well, the index, which is the day that we're in. From 0 to 5. Whether do we have a stock? Do we have a stock? And also number of transactions, right? So that's kind of the states that we kind of have, and you could actually incorporate all this into one function. But the way that I'm going to do it is going to be a little funky for this particular solution, just so that I demonstrate like there are different ways to solve problems. Don't feel like you need to tie down to over optimize as you need. Sometimes you just need to do the silly, easy, obvious things, or straightforward things. Yeah. So the way that I would do it is, okay. So I'm gonna be really explicit in how I do it. So yeah. So there are a couple of ways I could say, okay. So now the first thing that you can do is buy stock with 2 transactions left, right? So this is a really specific name. So yeah. So hopefully that makes sense. But basically, this is one of the state, which is okay. Let's say we have no stocks, so we want to buy stocks with 2 transactions left, right? So what does this mean when we have that? If day is equal to n, so okay, let's set what n is. Then that means that we're done. So then our profit is 0, right? Let's say if otherwise, now we have the price for a certain day, so we don't have a stock, so we want to buy a stock. So that means that our better performance will be either so the transaction is okay. So best buying stock now. Variable name is also a little funky, as I say, so play along with me. But just go to, okay, now we bought a stock, right? So we want to be able to go to a state where we're able to sell that stock later. Are those 2 transactions? Okay, I just want to make sure the definition of transaction, because I guess technically if you do any trading or whatever, you know that one transaction is just one buy or one sell, right? But I think they meant one pair of buy sell, so that's a little bit awkward in the terminology. But anyway, so now we have a stock, we want to go to, okay, so then the state changes to now we have a stock, so we sell stock with 2 transactions left, right? of day plus 1 because you can only sell the next day, right? And then what's the cost of this? This is minus prices of day because that's how much we paid for that's how much we paid for the stock that day. And then the other one is best not buying stock is equal to well, that means that you don't buy stock today, so maybe you buy the stock tomorrow, right? So buy stock with 2 transactions left of day plus 1. And then now we just have to return the max of both of these things because whatever gets you the max will get you the better overall profit, right? So okay, so then now we have to write out the other function, obviously. So now we want to do definition of sell. This is already done. Oops. And then now we go to sell. We want to implement this function of a given day, right? And for this, if day is equal to n, then we return 0. That just means you forgot to sell. So probably not. It's not. It probably isn't going to be your best move, but it's just what happens, right? You have a stock, you forgot to sell, so now it's worth 0, effectively anyway, I guess. And then now best selling stock now. Let's say we sell now. What happens? Well, that means now we have no more stocks, but then we can buy stock with 1 transaction left of day plus 1 because you can earliest you can buy is the next day. I mean, you could technically buy on the same day, but then you wouldn't want to sell anyway, right? So that's a little bit weird. So then now we get the money back on this day. So that's why we add the profits. Well, it's not really, it doesn't always have to be profits, but that's how much you get for the stock. And similarly, if you don't want to sell the stock today, then you could do it this way. And again, we just take the max of these two because recursively we always want to do that. Okay, so then now we have to implement this thing, right? So you get the idea here. I'm going to just do a little bit copy and pasting, to be honest, but you get the idea of what I'm trying to do, which is that, now we have 1 transactions left and 2 transactions left, right? And you go for all these states. So now I'm going to just do copy and paste, and you could kind of copy and paste your explanation a little bit, but replace numbers. So let's say buy 1 stock, or buy stock with 1 transaction left. Transaction. So this will be the same. And of course, if you're noticing the pattern, well, I hope you do. Then that's good because that means that you can see how to this is wrong, but we'll fix it. But you can see how oh no, this is right. But you can see how you could generalize this, right? Because now you have 2 transactions, 1 transaction, so that could just be a variable, and that could be like a k that you pass in, and that's how we actually solve the harder version of it. But for now, we're just going to stay with this. But now, let's say we sell stock. We sell it here. Actually, when we sell stock, we have no transactions left, so there's no state, so we can just remove this. And we're selling stock is equal to here. Yeah, same idea here. Oops, as long as you get the states right, and that's pretty much it. And then now to kick it off, we just return buy stock with 2 transactions left from 0. And then we can print it out. There may be performance issues, we'll see. It's small enough that I hope it doesn't, so that I could just illustrate it. Okay, so it does. It's either that I have an infinite loop, to be honest. Actually, I should, because this one is there's a typo here, because this should be +1, right? Might still time out. Okay, so it does actually not timeout because n is small enough that it's fast, but as you get more and more n, it's going to be really slow, right? So then the thing to notice is that when you write the problem recursively this way, what are the possible number of inputs today, right? Well, it's just n, because it could be day 1, or sorry, day 0, day 1, day 2, day 3, to day n-1, also day n, right? So you could definitely use memorization to memorize this, and you do it for all these functions. And because you're only memorizing for 4 functions, and each one of them has O of n, it's going to only take O of n space. And because each of these also only do O of 1 time, the entire complexity is going to be O of n time and O of n space. Yeah, and this is right, except for that for bigger n's, it's going to time out because we don't cache. I'm thinking, so I have a lot of videos of me doing the caching portion, so I'm just going to skip the caching portion now and just use a hack that's in Python to memorize this, and then yeah, just making sure, always running, pending. Pending it very slowly today. Let me refresh the page real quick. Oh, there we go, finished. And it looks good. And I think it was much faster. Okay, now it's refreshing, so maybe my internet is just slow, maybe. Sorry for this. But yeah, this is the risk of doing something live. Okay. And now let's submit. Unless I miss some edge cases, it should be okay. I think I'm a little bit lazy, and again, maybe my internet is just a little bit bad today. Maybe Frank. Okay, and there you go. Yeah, and I think the way that I break this down is how I would think about it. And of course, you're more experienced, then you should already be able to, change this into 1 function or 2 functions, depending on how you want to define it. Again, if you want to upsolve it, I'll post a link to the other problem that I solved for the other best time to buy and sell stock. Let me know what you think. Hit the like button, subscribe button, and join me on Discord. And I will see y'all tomorrow. Bye bye.